Alright guys, good afternoon. These are your notes for 9.2, data distribution and outliers. Okay, what data distribution is it helps us to describe the shape of the data. Okay. On dot plots, you can see this first one, we call it skewed to the right. So most of the data, actually, when it's skewed to the right, is on the left-hand side. So what we're referring to is there's a tail on the right. Okay, and so most of the data is to the left. When it's symmetric, it's a bell curve. Okay, and it doesn't have to be perfect. You don't have to have exactly the same amount on the left as the right, but it's approximately the same. And when data is skewed to the left, okay, there's a tail on the left. And most of the data lands on the right. Okay. Today we're going to talk about how to actually find an outlier. We've talked about that an outlier is a number that's significantly smaller or significantly larger. So an extreme value that does not fit in with the other values of the set. It's the outlier, and it's sometimes removed from the data set because it distorts the central value, or the middle of our data set, which is the easiest way to tell something about a set of data. So these are the two ways to calculate. If we want to know if it's below, and I'm going to say it's Q1 minus 1.5 times the IQR, and with the above, it's Q3 plus 1.5 times the IQR. Okay, and if the data falls below this number or above this number, once you've calculated it, you know it's an outlier. So we have this data set that we're going to do some calculations on, and they were nice enough to put it in order for us. So the first thing we have to do is make a dot plot and identify if it's skewed or symmetric, skewed left, or skewed right. So we're just going to go right along. 20, 25, 35, 40, 45, 50, 50, 55, 55, 55, 60, 60, 60, 65. So because our tail is to the left and the majority of the data is on the right, we're going to say that this data set is skewed left. Okay, the mean, what I would do, and I'm not going to take the time on the video just to save some time. When we get the mean, we add up all the numbers and divide by the amount there are. So the mean for this data set is 48.2. The median is literally the middle number. And I can tell you that happens to fall between 50 and 55, which makes that 52.5. And to get the IQR, we have to figure out quartile 1 and quartile 3. So quartile 1 is 40, and quartile 3 is the first 60 value. So we have 60 minus 40 gives us an IQR of 20. So it says if the number 100 were added to the data, would it be an outlier? Then explain. So I need to know, this would be an upper value. So I'm going to use the 1.3, or Q3, sorry, plus 1.5 times the IQR. So Q3 plus 1.5 times the IQR. So we said that quartile 3 was 60. So we have 60 plus 1.5 times, and then we calculated the IQR of 20. When that is calculated out, you should get 90. So that means any value above 90 for this data set is an outlier. So I would say yes, it is greater than 90. Okay. Number 6 says, which of these would be changed by adding 90 to the data? The mean, the median, and the IQR. So if I added the number 90, which technically is an outlier, the mean would go up. Remember, that's the average, and by adding a larger number, that would make my average go significantly higher. The median, which is the middle number, would change to 55. And the IQR would actually stay the same. Because if I move this to 55, the Q3 is still going to fall at 60, and that's not going to change. So that is how that would affect that. As far as the extra notes, to save a little bit of time today, I've gone ahead and written the data sets out from both of the examples. So if you need to pause and take some time to go ahead and write those out, please do so now. So we need to calculate the mean, the median, the IQR, and the standard deviation of these two shows. And what they are, it's the age of contestants in a show, in a TV show. So the mean is, again, the average. So I'm going to add them all up and divide by the total. So the mean for show 1 was 32.9. And the mean for show 2 was 32. The median, literally middle number, and that happens to fall here on both. So the median for show 1 is 32.5, and the median for show 2 is 33. The IQR, well, we have to do, this is Q1, and this is Q3. So again, for show 2, it's going to be Q1 and Q3. We're going to subtract those. So the IQR for show 1 is 16, and the IQR for show 2 is 12. And then standard deviation we did the other day. So when you calculate that, the standard deviation for show 1 is 10, and for show 2 is 6.5. And again, to save time, I'm not going to calculate them with you, but you do know how to do that. So when I compare them, the mean, let's say the average age, because mean is the average, is lower on show 2. And all we're doing is comparing them. So you could also say the average age is higher on show 1. The median, there are more young contestants on show 1. And again, all we're looking for is ways to compare the two sets of data. And when we're using the range and the IQR, you can see the IQR in show 1 is, and the standard deviation is higher than on show 2. So I'm going to say the ages of contestants on show 1 are further apart than show 2. Okay, because the range in the IQR is how it's spread, how spread apart our data is. Okay, so on questions like that, these are the type of answers that we're looking for. Okay, and then when we compare data distributions, this is from page 320, it's number 9. They had Team A and Team B listed, and what I did was make a dot plot for both. Team A, you can see it's it's like exactly symmetric. So I'm going to say that the distribution for Team A is symmetric. This means let me go back just a second. They were talking about free throws made per team, by the way. That's what the 0, 2, 4, 6, 8 is. Free throws made on each team. So this means the number of free throws is evenly distributed about the mean. Okay, and you can see it's exactly evenly distributed. There's 4 on either side. Okay, for Team B, this one is going to be skewed to the right. So the distribution for Team B is skewed right. This means that fewer than half of the team members shot a number of free throws greater than the mean. Okay. And then also, obviously, just exactly the opposite of that. If it were skewed left instead of right, I could say that fewer than half, or more than half of the members, shot a number of free throws greater than the mean. Okay, so we're looking for answers like this when you're doing your homework. Um, Speaking of, your homework is 9.2. It's on page 321. You're going to do problems 5 through 10 and 14 to 16. Thanks for watching, guys.